Today we are going to perform an experiment on static and dynamic vibration. Now moving to the introduction part. When a body or structure is disturbed from its position, it starts to vibrate. In static vibration, the system is in equilibrium under steady, constant load and deflection is measured. In dynamic vibration, the system is made to move and oscillate with the time are studied. This experiment helps us to understand how stiffness, mass, and damping affect vibrational behavior. The apparatus required are vibrating beam or spring mass setup, set of weights, vibration exciter or motor for dynamic test, function generator and power supply, dial gauge or displacement sensor, stopwatch or oscilloscope. The experimental setup includes this type of system where we can see the static vibration test and dynamic vibration test. The experimental procedure are for static state it is mount the beam or spring in the setup, add known weight one by one, measure the static deflection for each load using a dial gauge, plot a graph of load versus deflection to find stiffness. And for dynamic testing, apply periodic excitation using the vibrator or motor. Gradually vary the excitation frequency. Note the amplitude of vibration at each frequency. Identify the frequency where the amplitude is maximum. This is the natural frequency. Compare experimental natural frequency with the theoretical value. The conclusion for this experiment is the static test helps us to determine the stiffness of the system. The dynamic test shows how vibration amplitude changes with the frequency. Maximum vibration occurs at the resonance natural frequency. The experimental setup demonstrates the relation between mass, stiffness and spring in both static and dynamic conditions. Today we are going to study the experiment on the static and dynamic balancing of rotating mass using the balancing apparatus. In a rotating machinery, unbalanced forces occur due to unequal mass distribution about the axis of rotation. Balancing is done to reduce vibration, increase machine life. Static and dynamic balancing both can be achieved. For static, the center of gravity lies on the axis of rotation. There are no unbalanced force when stationary. And for dynamic, achieved when there is no unbalanced force or coupled during rotation. The apparatus requires a static and dynamic balancing machine, set of rotating mass, disc with provision to add weight, measuring scale, tachometer, weights for balancing. The procedure is for static, mount the masses on the balancing shaft, allow the shaft to rest freely and note where it comes to rest. This indicates the heavier set. Add balancing weights opposite to the heavy set until the system remains stationary in all positions. For dynamic, mount the same masses on the balancing machine at angular position and radii. Run the shaft at low speed. Observe the vibration pattern or pointer movement. Using vector diagram, calculate the position and amount of balancing mass required. Place the mass at the calculated position. Repeat the same process. Now we can start the machine, right? So we can perform how it will actually look when the dynamic motion takes place. This is the dynamic in motion. Here we can see the machine has started rotational motion. There we have provided 4 rotational discs for the machine purpose and it is starting to get vibration. For vibration we can use different masses for balancing the machine.